Hey, what's going on, guys? In this video we are going to take a look at complex numbers. I have shown you guys addition, subtraction and also multiplication. Here I'm going to continue with the multiplication again, and also we are going to see some divisions as well. Now let's look at the question first. Let's say we have 5 minus 2i, and we have the conjugate of this one, 5 plus 2i. The short form of this method is whenever you see a conjugate and the original form, like when we have a minus and a plus of the same thing, that's what this one, and the conjugate of this one is this. And you can see whenever you see these kind of things, you can directly multiply this. 5 times 5, that's 25, and minus 2 times plus 2i, that's minus 4i square. You can directly just multiply like this and get the final answer, that is 25, this is I square, and 25 minus 4, I square is -1, so 25 plus 4, that's 29. Now you can also go ahead and do it in the long way. To do it in a long way, what you have to do is you have to FOIL it. Let's try that one as well. You have to just FOIL it. 5 times 5, that is 25. 5 times 5 is 25. 5 times 2i is plus 10i, and minus 2i times 5 is minus 10i, and then minus 2i times plus 2i, that is minus 4i square. And you can see the mid two term cancels. That's why we can just directly multiply this one like this, because the midterm will cancel when you have a conjugate of a number. Like here we have this number and a conjugate of this. So whenever you have that kind of situation, when you FOIL it, you will have the middle term cancelled. That's why we can directly write 25 minus 4i square and get the final answer, that's 29. Okay, that's the first one. Now let's look at another question. Let's say we have something like this: 3 times 7i whole square. And here what's going to happen is this square is going to be distributed for 3 and the 7i as well. So we are going to get 9 times 7i whole square, and 9 times 49 times I square. 9 times 49 is 441. I square is simply a -1, so this is going to be negative 441. Now let's try a different example. Let's say we have something like this. Let's say we have 3 plus 7i square. For this one we have to FOIL it. We have to just expand it and FOIL it. 3 plus 7i, 3 plus 7i, 3 plus 7i, 3 times 3, 9, 3 times 7i, 21i, and then 21i, and then 7i times 3, 7i times 3 is again 21i, plus 49i square. Okay, 9 plus 21i, 42i, and then 49i square. 49i square, I square is -1, so we are going to get 9 plus 42i minus 49. Minus 49 plus 9, we are going to get minus 40 plus 42i. That's our final answer. Now let's look at another question. Let's say we have a question like this. Let's say we have a division: 4 plus 3i over 5 minus 2i. Whenever you see a division like this, the first thing we can do is we can multiply the denominator by its conjugate. So the conjugate of this denominator is 5 plus 2i, but if you do this thing for the bottom, you have to do it for the top as well. 5 plus 2i in the top, and let's simplify the top first. For the top part, okay, it's loading. Okay, now let's do it until it's done. I can write it. but I can talk. 4 times 5 is 20, so we are going to get 20. Okay, now it's okay. 4 times 5 is 20, and 4 times 2i is 8i, and then 3i times 5 is 15i, and then 3i times 2i, that's gonna give us 6i square. 6i square. In the meantime, I can simplify the bottom as well. 5 times 5, 25, and this is conjugate, and whenever we see conjugate we can directly multiply this. That's minus 4i square. So finally we are gonna get, I continue here. Finally, if we simplify the top part, we are gonna get 20. 15 plus 8 is 23i, and then 6i square. I square is -1, so we are going to get -6 right here. And in the bottom, I square is -1, so -1 times 4, positive 4, so we are going to get 25 plus 4 here. In the top part, we can simplify this one furthermore. That's 20 minus 66 is 14 plus 23i, and in the bottom 25 plus 4, 29. But however, whenever you have a question like this, you have to always try to bring it into the standard form. The standard form is of a complex number is a plus bi. Okay, so what we can do to get to this form, we can just distribute the 29 for both of this, like 14 divided by 29, so we have a whole number, and 23i divided by the 29, so we have imaginary number separated, and that's our final answer. Now let's look at something more. I'm going to get rid of this part. Okay, now we have done the division right here. Now let's look at something more. Let's say we have something like this: 8 over 6 plus I. Again, whenever we see question like this, what we have to do is we have to multiply the denominator by the conjugate, but if we do it for the denominator, we have to do it for the numerator as well. So first I do it for the denominator, 6 minus 4i, and we do the same thing for the numerator, 6 minus, actually I, not 4i. Okay, I want to erase that. Again, it's loading. I'm waiting for it to respond. Okay, 6 minus I, 6 plus I, we are going to get 6 minus I, and then we are going to continue. I'm waiting for it to respond. Okay, now it's responding. Now I erase this 6 minus I. And here 6 minus I. Now if we simplify the top part, we're going to get 8 times 6 is 48, and minus 8i. In the denominator, we are going to get 36 minus I square, and in the numerator we can keep it as it is, 48 minus 8i. In the denominator, we can simplify this one furthermore. I square is simply -1, so negative 1, positive 1, so we are going to get 37 in the denominator. And to finally we have to give it in a plus bi form. To do that, we just have to separately distribute this 37, so 48 divided by 37 minus 8i divided by 37, and this is our final answer. Now let's try this problem. Let's say we have something like this. Let's say we have a question like 7 plus 2i divided by 3 minus I. Again, whenever we see a question like this, we can just multiply by the conjugate. See, for the bottom part, 3 plus I is the conjugate of that, and if we do it for the denominator, we have to do it for the numerator as well. So this is going to be 3 plus I in the numerator as well. Now let's go ahead and simplify. Here I'm going to erase this part. Okay, I'm going to continue here. 7 times 3 is 21. 21 plus 7 times I is 7i, and 2i times 3 is 6i, and then we are going to have 2i times I is 2i square, and in the denominator 3 times 3 is 9 minus I times I is I square. So we are going to, if we simplify this one furthermore, 21 plus 13i plus 2i square, 2i square divided by 9 minus I square, that is minus 1, and in the numerator if we simplify this one, 21 plus 13i 2i square is negative 1, so negative 1 times 2, negative 2, and in the bottom we are going to get 10, and then 21 minus 2 is 19, so 19 plus 13i divided by 10. So finally we have to give it in the standard form a plus bi. So we just try to divide 19 by 10 and also the 13i by 10 separately, and that gives us the standard form. And let's look at another one. Let's say we have a question like this. Let's say we have a question asking to divide 5 minus 2i. Okay, I'm gonna erase this. Okay, let's say the question is asking 5 minus 2i divided by I. Okay, whenever you see I alone or any I multiplication, you have to see how you can bring it into I square, if it I square, and if it above, how can you bring it into I power 4 or something like that. In that way it will be easy, because I power 4 is 1, so that will become easy, or I square is negative 1, so both way it's easy. Now here we can make it to I square. To do that we just have to multiply bottom and top by I. 5 minus 2i, and here I square. The reason to bring it is we have to give the final answer in a plus bi form, so that's what we are targeting. And here I multiply the top by I as well. Bottom I didn't show multiplication of I, but I times I square. Okay, I multiply by I, and here what we are going to get is 5i minus 2i square, in the denominator minus 1, and 2i square is 2 times negative 1, so positive, negative 2, negative, negative, positive 2. 5i plus 2 divided by negative 1. Now we have to give it in a standard form, that is a plus bi form. So when you divide this one by negative sign, negative 1, the whole thing become negative, like this will become negative 2, negative 5i. That's our final answer. Now let's look at one more and we are done. Okay, let's say we have a question like 3 plus 2i times divided by 7i. Here again we can, if we see I alone, we can try to make it to I square. To do that we just try to multiply by I. So we are going to get, we are going to have 3 plus 2i multiplied by I, and in the denominator 7i multiplied by I. In the numerator we are going to have 3i plus 2i square, in the denominator 7i square, and let's distribute I square -1 for all the I squares. 3i I square is -1, so -1 times 2, we are going to get -2, and in the denominator I square is -1, -1 times 7, -7, and if we write it in a standard form, -2 over -7 plus 3i over -7, and if we distribute the negative, the first one becomes this 2 over 7, and the last one minus 3 over 7i. Let's see if I made any mistake here. 3i 2i square, that's -2, so 3i minus 2 over -7. Now -2 over -7 and -3 over 7. Okay, that's our final answer. Now we are done, and I'm going to do more complex numbers. I'm keep doing it. This is my 5th complex number video. I'm going to do more of that and upload in my next video. I hope you guys find this video helpful. Thanks for watching, and see you guys on my next video, and don't forget to subscribe my channel.